Hello everyone, welcome to my YouTube channel. My name is Shane Benga. We will be looking at compare means today. So compare means is one of the best estimation parameters that is used to compare the mean of two or more groups to check if there is differences and also to check if they are statistically significant. So today we will be looking at compare means. So what are the learning outcomes today? Well, we will be looking at the mean of compare means, the types of compare means estimation techniques. We'll be looking at the meaning and examples of compare means estimation techniques, and we'll also be looking at some examples of Minitab and SPSS using independent sample test as a case study. So what is compare means? Compare means test, it helps us to statistically determine if one or more groups have similar means. And then what are the types of compare means estimation techniques? We have two types of compare means estimation techniques based on the nature of the data. You have the parametric text and also the non-parametric text. So if your data sets are normally distributed, then your data set, you need to observe a parametric text. So the following are the types of parametric text under compare means estimation techniques. You have the independent sample t-text, you have the paired sample t-text, the one sample t-text, and also we also have the one-way ANOVA test. So if your data set are not normally distributed, instead of you comparing the mean, you have to compare the median. So the following are the non-parametric tests. We have the Mann-Whitney test, the Way-Cutting rank test, the one sample Way-Cutting rank test, and also the Kruskal-Wallis H test. So the first we'll be considering today under parametric test is the independent sample t-test. So independent sample t-test is also known as the independent t-test, independent measure t-text, independent two sample t-text, student t-text, two sample t-text, uncorrelated score t-text, unpaired t-text, as the case may be. So depending on the software you're using to run your analysis, so if you come across these terms, definitely you are still looking at independent sample t-text. So what is independent sample t-text? The independent sample t-text compares the means of two independent groups in order to determine whether there is statistical evidence that the associated population means are statistically different. So if you're comparing the means of two groups, then you need to observe independent sample t-text. So what do you need to run an independent t-text? You need two things to run independent t-text. The first one is you need one independent categorical variables that has two levels or two groups. So it can be a male and female group. And you also need one continuous variables such as age, scores, or salaries, and so on and so forth. So one of the conditions is that your continuous variables must be normally distributed before you can consider independent t-test. So the second parametric test we will be looking at is the paired sample t-test. The paired sample t-test is also known as the dependent t-test, paired t-test, or repeated measure t-test. So what is paired sample t-test? A paired sample t-test compares the means of two measurements taken from the same individual, object, or related units. For example, if you want to check the mean of the scores of a student before COVID and after COVID, then you should consider a paired sample t-test. It compares the means of two measurements taken from the same observations. So what do you need to run a paired sample t-test? You need a dependent variable or a test variables. So this test variables is usually a continuous variables. And before you can consider a paired sample test, you need to check if these data sets are normally distributed. So if they are normally distributed, then you need, and you want to check check for the measurement of two different times, either before COVID or after COVID, or before an era or after an era, then you need to consider a paired sample t-test. So another parametric test that we'll be looking at today is one sample t-test. The one sample t-test is also known as a single sample t-test. So what is a one sample t-test? The one sample t-test examines whether the mean of a population is statistically different from a known or hypothesized value. So if you want to check the differences between the mean of a population and the mean of a known or hypothesized value, which can be gotten from a literature or from the observations or from experiments, then you need to consider a one sample t-test. So what do you need to run a one sample t-test? You need a test variables. And this test variable, one of the conditions is that these test variables must be normally distributed. And you also need a test value. This test value can be gotten from observations, can be gotten from an experiment, can be gotten from a literature review. So the last parametric test we will be considering today is one-way ANOVA. The one-way ANOVA is also known as the one-factor ANOVA and one-way analysis of variance and between subject ANOVA. So one-way ANOVA, also known as analysis of variance, it compares the means of two or more independent groups in order to determine whether there is a statistical evidence that the associated populations means are statistically different. So the difference between one-way ANOVA and independent sample t-test is that the independent sample t-test focus on two independent groups to compare the means of two independent groups if they are statistically different or if they are statistically significant. Whereas one-way ANOVA compares the means of more than two groups to check if there's any statistical differences are also just statistical significance among the groups. So what do you need to run a one-way ANOVA? You need a dependent variable and also need an independent variables or a grouping variable or a factors. So these independent variables must be more than two groups, and then your dependent variable, which is always a continuous variable, must be normally distributed before you can consider a one-way ANOVA. So the first thing that you need to do before you consider any estimation parameters is to check if the data set are normally distributed. And that is why there's always a saying that for every parametric test, there is always a non-parametric test. So if you're considering an independent t-test, independent sample t-test, and you want to compare the means of two groups, and your data set is normally distributed, then you need to consider an independent sample t-test. But if your data set are not normally distributed, then you need to use the man-Whitney test. So if you want to compare the mean of an experiment, of a single experiment, you want to compare the periods. For example, like I explained before, you want to compare the scores of a student before COVID and after COVID, then you are using a paired t-test. So if your data set are normally distributed, you will be using a paired t-test. But if your data sets are not normally distributed, you will be using the equivalent Wilcoxon rank t-test. So one sample t-test, the equivalent one sample t-test is also known as the one sample Wilcoxon rank test. And also, if you're checking the mean of more than two groups, if your data set is parametric, you will be using one-way ANOVA. And if your data set is not parametric, is not normally distributed, you will be using a Kruskal-Wallis H-test. And that is why there's always an equivalent parametric test with a non-parametric test. So our next example is we'll be looking at examples of Minitab and SPSS on how to run an independent sample t-test. So the first one we'll be considering is an SPSS. So this is our SPSS, this is our data view, this is our variable view. Under our variable view, we have the test scores, and the labels is the test scores for students in a class. So under our gender, we have the male and female. This is the value. 1 represents the male, while 2 represent the female. So our data set is ready. These are the scores: 14, 14, 14, 14, 15, 15. And this 1 represents male, male, while 2 represent female. So our data set is ready for analysis. So you click on Analyze, you click on Compare Means. Like I said before, and we're looking at independent sample t-test. So to compare the means of two independent groups. So you click on independent sample t-test. So your test variables will be the test scores, while your grouping variables will be the gender. You have to define the group 1 for male, group 2 for female. You click on Continue, and you click on OK. So automatically it brings the result for you. So this is the group statistics. You have the test scores of students in the class, the gender, male and female. The number of observation is 30 for male and 30 for female. The mean is 4.3 to 11.36, the standard deviation. So if you need this information, you can as well use it. But we'll be focusing on independent sample t-test, the test scores of students in the class, equal variances assumed. So if you look at this test, you need to check for the significant value. The significant value is 0.00. 0.00. You can check the value here. It's 0.00000000. So, and this shows that the value is less than 5% level of significance, which is alpha. So, from these results, we can conclude that we need to reject the null hypothesis and accept the alternate hypothesis that there is a statistical differences between the scores of male and female in the class. So this is a typical example of how to run a dependency test on SPSS. We can check for how to run dependency test on Minitab. So this is the Minitab as well. This is the worksheet for the Minitab. We have the test scores. We also have the gender. The 1 signifies for male, while the 2 is for female. The data set is ready. So what you need to do is you click on Start and also Basic Statistics. Like I said before, on Minitab, independent sample test is known as a 2-sample t-test, and that's why you need to be conversant with the terms of these estimation parameters. It's usually used to compare the mean of two groups. So you click on independent 2-sample t-test. The first thing you need to check is you need to click on this icon. Both samples are in one column. Is that the nature of your data set? Each sample is in its own column and summarize data. As you can see from our data set, both samples are in one column. So you click on both samples are in one column. Then samples, towards your samples, the test scores, you click on select, you come to the sample ID, click on gender, click on select, and you also click on options. So we have the 95% confidence level. And then under the alternate hypothesis, you need to check, what do you want? Do you want your alternate hypothesis to be the differences is not equal to hypothesized difference? Or do you want the difference is less than hypothesized difference, or the difference is greater than hypothesized difference? So for the purpose of this illustration, I will be checking the differences is not equal to hypothesized difference. So I click on OK and also OK. So just like the same with SPSS, you will be having the descriptive statistics of test scores, the gender 1 for male, and the 2 for female, observations, the mean, the standard deviations, and the standard error mean. We also have the estimation for differences, and also we have the test. So as you can see from the p-value is 0.00, which is also less than 5% level of significance, 5% level of which all can become our 5% alpha. So, and from that, we can conclude that we should reject null hypothesis that and accept the alternate hypothesis that there is significant difference between the scores of a male and the female in the class. So this is a typical example of how to run an independent test. The first thing you need to do is to determine what are your objectives. Are you comparing between two groups? Are you comparing between more than a